Hi, this is Dave LeMay, and welcome to our second video in a series of videos on Java programming for First Robotics. This series of videos is going to be about different techniques of programming that we can use in Java. It is not meant to be an introduction to the Java programming language. It assumes some background in Java programming and in programming in general. It assumes that you perhaps are in the middle of a high school course on Java programming, or that you have taught yourself via the various web classes and books available. However, what this video series is going to be doing is going into some detail about things that, as a mentor for the last 7 years, I've observed are sometimes not taught. The first couple of videos, including this one, are going to be about some very basic programming elements, but perhaps they were skipped in a particular setting because they weren't important there. But I've run into them in First Robotics, and I've seen students that have not learned them. And so the first video that we're going to do today is about variables. You know what variables are, you declare them and then you store things in them, but I'm going to be telling you a little bit more about them today. In particular, we're going to be dealing with only primitive variables. Java has two sorts of variables. There's the primitive variables, and these are built into the language. They have definitions outside of your program. These are things like ints and chars, things that you can't change that are normally just elements of the programming language. Their names are keywords. You can't redefine them. This is opposed to class variables or reference variables. Those will get a little more complicated, and those will be the subject of the next video. This one is going to be only talking about different elements of primitive variables. So let's get started. All right, to talk about variables, we're going to talk about primitive variable types today, and the first set that we're going to talk about are integers. There's 4 different ways to represent an integer in Java, and that depends on the number of bits you want to use. 1 byte is 8 bits, and so for small numbers you might use a byte. For very long numbers you might use a 64-bit number, which is a long. 32 bits are an integer. That'll let you store up to about 2 billion plus or minus. In Java, all integer types are signed, meaning they can be either plus or minus. In some other languages, you specify whether you want positive and negative, or unsigned, which is just positive numbers and 0. The one that you choose will determine the range that you can represent, and so the question for us is which one should you use, and the answer is int. Now the other answer is a lot more complicated, but for our purposes you can always just use an int to store anything, with one exception. That one exception is time. This function here, current time milliseconds, that returns the number of milliseconds since an important event. In the case of the RoboRio, that important event is the point at which you turned on the robot. So 10 seconds after you turn on the robot, this will return the number of milliseconds that have passed, or 10,000. And because in a real system that might sit on a factory floor, it might not be turned off, a int can only store up to 2 billion, which is about 24 days. And you might have machines that run for a lot longer than 24 days. So this always returns a long, and you have to be aware that you're returning a long and treat it accordingly. So I've talked about what to use as an int, but what are these things? When you declare a variable, what are you actually doing inside the computer? The compiler knows that it's a value that can store numbers between its largest range, but what is actually going on that allows the computer to store that? Well, for that we have to look at the computer's memory. All right, we've been talking about variables, and we know that they're used to store values, but what are they really? Well, they're locations in memory. Your computer might have 4 gigabytes, which is roughly 4 billion bytes of memory, and each of those bytes can be used and referred to with a number, and that number is called its address. This is an address. Gotta correct this. Okay, so you might have an address of 1000, that's this byte. 1001 is this byte. It might have multiple bytes in a row used to store the same value. Remember we said an int takes 4 bytes to store. Well, there are 4 bytes in a row. And when you declare a variable like this, what happens? The compiler looks and says, oh, he's going to want something called a, and it's going to be an int. And every time I see a from now on, I'm going to know that he means wherever that thing is. And an int takes 4 bytes, so I'm going to go over here, and I'm going to take the first available 4 bytes, and I'm going to say that's what int a means. Oh, I'm going to put zeros in all of them. When I declare a short, it's going to put 2 variables in here. When I declare another int, it's going to put another 4 variables. A byte would be 1. Strings and other reference types are a little bit different, and we're not going to cover those in this video. When you do an assignment statement, such as a equals 3, that's an assignment. You're saying take the value 3 and put it in a. Well, we want that to be lowercase, don't we? Case matters. Capital A is not the same thing as small a. So a equals 3. We're going to say, find the thing that I called a, that was over here at 1002, and put 3 into it. 3. There it is. That's what an assignment statement does. It says, look up that address and stick that value in it. If I said, int c equals 1,000,000, this is a representation of 1,000,000. It's 15 times 65,536, which is 2 to the 16th. So 15 here, 66 times 256, which is 2 to the 8th, plus 64, that's equal to 1,000,000. So this is 1,000,000, and it's in this place where we called C. If you don't understand this math, don't worry about it. But look up binary math, and you'll see that this is 32 bits, and it comes out to 1,000,000. So that's what a variable really is. It's a place for the compiler to store a value. That'll become more significant when we talk about reference values and understanding that each memory location has a number that is used as an address. That'll be important in reference variables. For now, you just know that when you declare a variable, this is declaring a variable, it sets aside a location of memory for later use. When you assign to a variable, this is assigning to a variable, it actually changes the value that is stored in the memory. So with that in mind, let's go back to our video. Okay, so a couple of pitfalls that we deal with integers, now that we know how to store them. What if you actually need to work with something and it's not the right type? We do something called casting. If you ever see a variable name or a variable type in parentheses with nothing else, what it's doing is something called casting, which is telling the compiler to treat the thing that follows it as if it were this type. In other words, here's a long, called now that we got from system current time milliseconds, and we want to treat it as an integer so that we can do some math on it and store it as an integer. So if I take now minus 1000 milliseconds, if I tell it that now is an int, it'll represent that as an int, subtract 1000, and give me the value. If I didn't do that, I would get this red line and a type mismatch because it knows now is a long, and I can't put a long value into something that only has space for an integer. So it's going to give me a compiler error and not let me do that unless I cast it. Casting is a bit dangerous because if the real number is more than 2 billion in this case, slightly more than 2 billion is the actual value, max int is the number, then this calculation will end up giving you the wrong answer. So you have to be very careful when you're using time to know that you're less than 2 billion milliseconds, or else you might end up with an incorrect response due to errors of rolling over past what an int can store. In the case of the RoboRio, we're never going to leave our robot on for 24 days, and that's 2 billion milliseconds, so we'll be fine. There's a different problem that comes up in the case of floating point numbers. Floating point numbers can be stored as floats or as doubles. Always use a double. Double means double precision floating point number. Floating point is anything with a decimal representation. So the double uses more places after the decimal point to approximate a value. It can also use scientific notation if you ever see something like that. Returned, E stands for exponent, 1.23 with an exponent of 5, which is 1.23 times 10 to the 5th. So when you see that printed out, you know that it's scientific notation, and you can use that in your programs, or it might print it out from the result of a calculation. The difficulty with floating point numbers can be round-off error. And so suppose you have something like this, 1/7 is equal to 1.0 divided by 7.0. All right, that's all very good. Now let's add that together 7 times. The answer should be 1. So if 1 equals 1, print they are equal, else print they're not equal. Well, if I were to run this, I would say they are not equal. And the reason for that is that I've had some round-off error in my calculation. Let's demonstrate. Here we go. Start debugging, and there it goes. And they are not equal because 0.99999 and etc. is not equal to 1.0. So be very careful when you're comparing floating point numbers, because unless they are exactly equal, you will get an invalid comparison. And generally, if any calculations have been done on them, they will usually not be exactly equal. They will be almost equal, and so you have to be careful when you're doing that. Another problem that you have with integers, going back to that, is division on integers. If you have an int divided by an int, so here I have upstairs equal to 7, downstairs equal to 10, I take an int divided by an int, I expect to get 0.7 back. If I didn't have this cast here, it would be an int divided by an int, and it would treat the value as an integer. Well, 0.7 is not an integer. It would end up rounding the result to the nearest integer by throwing away the remainder, and so you get 0. To get around that, I have a double upstairs, and as long as either one of these is a double value, then it will it will treat it as a double and give you the right answer. Okay. The next type of variable is a Boolean. Those can be either true or false. And the final type is a char. Those can represent a letter, and that letter can be in any language. These are 16-bit letters that use the Unicode alphabet. You can look it up on Google, and it represents any spoken language in the world today. Any character from those can be represented by a single char. All right. Another type that you're going to see a lot and that you are going to use a lot is the string type. This is not a primitive data type, so I'm going to talk more about strings in the next video when I talk about reference types. Strings are actually not a single value, they're a collection of values. They're used as reference types, and so we're going to save reference types to the next video. The next topic I'd like to discuss is static variables. We use those actually a lot in First Robotics, but there's often a lot of confusion among students because they've never run into the concept before. So what does a static variable mean? Well, in Java, everything is part of a class. All variables have to be part of a class. And normally, when you create a new class, you create all the variables that go along with it. So, for example, I've created this class called match. If I create a new match, I get a new R1, I get a new R2, I get a new R3 to go with that particular object that is an instance of class match. But suppose this class is intended to keep track of activities within matches. And suppose we want to keep track of the highest score yet achieved. Well, that's obviously going to be the same for all classes. So I only want one of them. And that's what I use static for. If a variable is labeled as static, it means there is only one across every instance of the class. So I have public static int. That means give me a variable of type int, but only give me one of them. It's the same for every class. They all have the same. And let me show you how that works. In this demonstrate static, I'm going to create match 1, and I'm going to create match 2, and then I'm going to say sample match 1.highscore. So find the variable associated in sample match 1 with high score and set it to 150. And then I'm going to print out the value of high score for sample match 2. I haven't touched sample match 2, so let's see what happens. And you should probably be able to figure out what's going to happen. And we run it, and look, it prints 150. That's because there's only one. When I changed to the one for sample match 1, it also changed the one for sample match 2 because they're the same sample. They're the same variable. Also, look, you've got this squiggly line, and it's saying the static field should be accessed in a static way. What does that mean? Well, take a look at the problems list. Here's where it is. The static field should be accessed in a static way. Notice it's a yellow triangle. That means it's a warning. It's not an error. If it was an error, it would be a red X. But it's saying this isn't the right way to do this. What is the right way to do this? The answer is to use the name of the class instead of the name of the object. So like this, match.highscore. Notice no line. Now it still works the same way if I do this. In fact, let's do it. I'll run without debugging. And look, sample match 2.highscore is equal to 150. There we go. Because when we changed it for the class, it changed it for every instance of that class as well. So static means there's only one, they're shared, and it's better to only access it by the name of the class. So if you ever see a name of a class followed by a dot, it means find the static variable of that class. It could also be a static function. We'll get to functions later, and use that. We do use those a lot because there's an awful lot of things on our robot for which there is only one of them, and we want to access that one thing without necessarily even creating an instance of the class. It's a good way in a Java program to create global variables because everything has to be part of a class. But if we create a static, we don't notice I don't even need to create an instance. I could get rid of these news and I'd still have an access to the high score. And last but not least, there's going to be one more topic on this lesson about variables, and that's the word final. Here we have final int left wheel motor equals 1. When you see final, that means you can assign a value to it once, which should be done when you declare it, and you can never assign it again. If I try to go into this and say sample dot left wheel motor equals 5, red line, and so it's saying the final field cannot be assigned. So, and this is an error, a red X there, so it won't let you do that. Final is used for things that will never change. They will be declared once. Why do we use them at all? What's the point of final? Well, it's often used for things that you know will never change and where you don't want to declare a number because it's harder to find and harder to figure out what these things mean. In particular, here's a great example of when we'd use a final. Left wheel motor. What I'm saying here is that the port that I'm going to use for the left wheel is number 1. And then in every case, I'm going to, instead of writing 1, I'm going to write left wheel motor. Boy, that's a lot more writing. Why would I do that? Why wouldn't I just say 1? Well, the answer is twofold. First, and most importantly, people can read it. People can know what you're talking about. I'm going to do things to the left wheel motor, and if I just say motor 1, then somebody's going to have to look up and figure out which motor that is. If I say do it to the left wheel motor, well, they know what it is then. So it's good programming practice. We'll go over that in a later variable about good code versus bad code. And it's good to use these sorts of things, but we call them final so that no one will ever change them. Another thing you'll notice, I printed this all in caps, all capital letters. Frequently, things that never change, that are declarations of constants like this, are done in all caps. That's not a language rule. You can print them in any size character you want. But all caps is a convention, and we should use it because people recognize it. They'll know that that means, this is a constant. This is something. Without even looking at the final, even if it just appears in your code, we can see it. All caps is something that never changes. Like I say, it's not forced, so you can do it another way. The compiler is perfectly happy, but you always want to write code that other people can read and understand, and that's a convention. As long as I'm talking about that kind of convention, you may notice something else that I do frequently, although not necessarily every time. And that is that things that I create for variables or functions always start with a small letter, but if they're multiple words, it uses larger letters. That's something called camel case, it's called. It's a combination of upper and lowercase. We'll go into it in more detail later. For now, don't worry about it. It's not important. But if you see an example where there's a small letter and then capital letters later, it's not wrong. In fact, it's recommended to write it that way, but you don't have to. It's a convention, it's not a rule. So let's go over the important points here that we've talked about in the video. There's really not very many of them, and even though it took a long time to say them. Always use int for integer values. Always use double for floating point values. Those are things that require a decimal point. If you need to switch between types, for example, if somebody else has used a long or a short or a byte, you can use casting to change the type of variable and use it as if it were the type that you need. If a variable is static, it means there is only one copy of the variable for every object in the class. They all use the same one. To access it, use the class name instead of the object name. If a variable is private, it means that a variable can only be used inside a class. If it's public, it can be accessed from anywhere. Public always works, but it might not be the best idea to use public. But if you aren't sure which one to use when you're writing code, use public. Always make sure to use something, though. Don't leave it to the compiler to decide. Don't leave it blank. If you see final, it means that once you assign a value, you can never change it. Those are used for constants. The way we use them most often in First Robotics is to access the positions of things on the RoboRio and where we have plugged things in, because that will never change during a match. Variable names typed in all caps usually refer to the constants that never change. So if you see all caps, that's probably a sign that it's a variable. It's a good idea to do it this way, but the compiler will not force you. Okay, thank you for watching. That concludes our video on primitive variables in Java. The next video in the series will be about reference variables. If you're on Team 247, feel free to contact me with any questions. Everyone else, feel free to leave some feedback in the comments section below if you're viewing this on YouTube. And we'll see you with the next video.